This is a concise overview on the reduction of air pollution. Air quality refers to the health and safety of the atmosphere, and it's determined based on the amount of pollutants that are in the air. Air pollution includes compounds such as volatile organic compounds, carbon monoxide, ground level ozone, sulfur dioxide, nitrous oxides, gaseous lead, and particulate matter. According to the Cary Institute for Ecological Studies, these compounds make up less than 1% of the atmosphere, yet they are very important for making sure that we and the environment are healthy. The average adult breathes over 3,000 gallons of air every day, and it matters what is in the air that we breathe. Ahead, we'll be looking at the technologies and regulatory frameworks that have been used to reduce air pollution in the United States. The desired outcome of this discussion is to gain an understanding of how human activities have physical, chemical, and biological consequences for the atmosphere. The learning objective is to explain how air pollutants can be reduced at the source. As part of the discussion, we'll be looking at the regulatory practices, conservation practices, and alternative fuels, as well as some of the key technologies that have been utilized to reduce air pollution in the United States. A key technology that serves as a system designated to capture displaced vapors that emerge from inside a motorist fuel tank is a vapor recovery nozzle. According to information from the Petroleum Equipment Institute, gasoline vapors accumulate in automobile and truck tanks above the liquid level. When tanks are filled, the rising liquid forces these vapors to seek an escape route. When a conventional nozzle is used, the displaced vapors flow out and around the nozzle spout and into the atmosphere. When thousands of vehicles are refueled, especially in an urban area, the escaping vapors add significantly to the region's air pollution. In areas where air pollutant is serious, environmental regulations require the use of Stage 2 gasoline vapor recovery systems. Such systems are referred to as Stage 2 because they address the second phase in the capture of vapors at a gasoline station. Stage 1 refers to the capture of gasoline vapors when fuel is delivered to the station's storage tanks. There are two basic types of Stage 2 systems. One is a balance system, which transfers vapors from the vehicle tank to the station storage tank without the assistance of an external force, such as a vacuum. The second type of system is one that relies on a vacuum source to help move the vapors out of the vehicle tank and into the storage tank. A key feature in the balance system is a hose nozzle that makes a tight connection when the pipe is on the vehicle fuel tank. The nozzle spout is fitted with an accordion-like bellow that pressures snugly against the fuel pipe lip. Balance systems are designed with controls that prevent fuel from flowing into the vehicle tank unless there's a tight connection between the nozzle and the bellows and the fuel pipe. A key technology that has been developed to reduce the amount of air pollutants that are generated by the internal combustion engine of a motor vehicle is a catalytic converter. A catalyst is a substance that causes or accelerates a chemical reaction without itself being affected. In a catalytic converter, there are two types of catalysts at work, a reduction catalyst and an oxidation catalyst. In this discussion, we'll be focused on a reduction catalyst, but in both cases, there's a ceramic structure coated with a metal catalyst. The idea is to create a structure that exposes the maximum surface area of the metal catalyst to the exhaust stream. But you also want to minimize the amount of catalyst required because these materials are often extremely expensive. The reduction catalyst is the first stage of the catalytic converter. It uses a metal catalyst to reduce nitrous oxide emissions. When nitrous monoxide or nitrous dioxide molecule contacts the catalyst removes the nitrogen atom out of the molecule and holds onto it. This frees up the oxygen to form harmless atmospheric oxygen. The nitrogen atoms bond with other nitrogen atoms that are stuck together on the catalyst, which forms atmospheric diatomic nitrogen, which is also harmless. Most modern cars are equipped with a three-way catalytic converter, which refers to the three regulation emissions that it helps reduce: nitrogen oxides, sulfur dioxides, and carbon dioxide. There are a number of pollution control devices that have been developed to remove harmful air pollutants from the atmosphere after combustion of fossil fuels. Specifically, a pollution control device is a device that's used after combustion to remove harmful air pollutants such as nitrous oxides, sulfur oxides, and particulate matter. Some examples include a fluidized bed combustion, which burns granulated coal in close proximity with calcium carbonate. The heated calcium carbonate can absorb sulfur dioxides. Another example is a baghouse filter, which allows gas to pass through but can remove particulate matter from the air. A wet scrubber uses a combination of water and air and can actually separate and remove particles from the atmosphere. An electrostatic precipitator uses an electric charge to make particles coalesce so that they can be removed from the atmosphere. The United States regulatory framework aimed at controlling and reducing the amount of atmospheric pollution includes the following. The Clean Air Act of 1970 is a comprehensive federal law that regulates air emissions from stationary and mobile sources. The Clean Air Act requires the EPA to set national ambient air quality standards for 6 common air pollutants. These include carbon monoxide, ground level ozone, lead, nitrogen oxides, particulate matter, and sulfur dioxide. The EPA must designate areas as meeting or not meeting the standard, and states are required to develop a general plan to attain and maintain all of the standards in all areas of the country. The EPA's Clean Air Markets Division runs a program to reduce air pollution from power plants to address environmental problems such as acid rain, stratospheric ozone depletion, particle pollution, and interstate transport of air pollution. Finally, the corporate average fuel economy standards are aimed at improving the average fuel economy of vehicles, which reduces the impartial combustion which produces many air pollutants.